Hi, my name is Jennifer Miller, and this is my Lab 2 Lines of Charge presentation. For the introduction, we will discuss the purpose of this lab, which, similar to Lab 1, is to conduct an experiment between everyday household items. In this lab, we will also determine how their charge characteristics affect one another. In comparison to Lab 1, Lab 2 does not consider the two pieces of tape to be point charges. Instead, we will acknowledge that the charge along the tape is distributed evenly across the length of the tape. For this experiment, we must make a few assumptions. The first assumption is that we must assume that there is no air resistance involved in the system. The second thing we must assume is that the pieces of tape are charged with the same amount of charge and, as discussed in the previous slide, this equal amount of charge is distributed evenly across the length of tape. There are also a few physics principles involved that we need to acknowledge. The first is Newton's third law. For every action, there is an equal and opposite reaction. In this case, the top tape is able to float because of the equal and opposite electric force that opposes the force of gravity. The next physics principle is the law of conservation of charge, meaning that charge is neither created nor destroyed but can be transferred from one system to another. This law comes into play when creating the U-tapes. We can also use the equation force equals electric field times charge Q to determine the force of each individual atom represented in the charge of tape. From there, we can use the principle of superposition to sum these charges together and determine the total electric force acting upon the tape. Finally, we know that when a system is in equilibrium, all forces must sum to zero and that the gravitational force and electric force should be equal in magnitude. On this slide, I have a few different pieces of data that are relevant to the experiment. This time, the experiment worked a little better, I think because I had experience creating the U-tapes from Lab 1. We can calculate tape mass the same way that we did in Lab 1 by multiplying the length times the given density. Then we know that gravitational force is calculated by mass times the gravitational constant. We also know that the electric force is calculated by the equation given in the previous slide. The estimated charge Q is bigger than it was calculated to be in the previous experiment. This estimation is reasonable because the tape is represented as a line of charge rather than a single point. Here is my code for Lab 2. The starter code set up the layout and then we had to fill in with our data. You can see my eField function from the previous two labs and then the line charge function which creates a line of n uniform point charges. Then, we create the two tapes, which are lines of spheres that model the individual sections of point charges in the whole tapes. Then, we calculate the electric field and the electric force. For the output, we can see that the line of red spheres represents the top tape and the line of blue spheres represents the bottom tape. Coming out of the individual spheres on the top tape are green arrows which represent the electric field from the bottom tape acting on the top tape. The white arrows represent the electric force of the bottom tape acting on the top tape, and the yellow arrow represents the force of gravity acting on the top tape. To conclude, I will answer the following questions. If I had modeled each of the tapes as a single point charge, the value of charge Q would have been much smaller than it was in this lab. Comparing the two charges, we can see that the charge in this experiment is estimated to be much larger than the calculated charge in Lab 1. We know that this is reasonable because the tapes in this lab are represented as line charges rather than singular point charges. These estimations differ because Lab 2 is more accurate than Lab 1. We know this because Lab 1 is more of a generalized model, whereas Lab 2 represents the physical tapes. The values calculated in Lab 2 are more accurate because there needs to be a greater amount of charge in order to float a whole piece of tape rather than just a singular point.